Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So this is the overview of the today's video lecture that we are going to cover. So we'll start with the material joining. Already in the last class, we have seen the broad classification of these joining processes. Today we'll start with this one and we'll come to our syllabus which starts with the welding. Then we'll see what the welding is. Then of course we'll see what are the advantages and disadvantages of the welding processes. Then we'll see how we'll classify the welding processes. And then we'll just start the briefing of all the welding processes and we'll start with the fusion welding. So this will be the last one for the today's lecture. So we'll start with the joining processes. Joining processes is a broad classification. Already we have seen means joining means it may be permanent joining, it may be semi-permanent joining, it may be temporary joining. So temporary joining means if two parts or more than two parts have been combined together. So if we have to dismantle these two or more parts, we don't have to physically damage the parts. That is, we have already seen this is the temporary joining. Semi-permanent joining means partially we'll have to damage the parts. But in our syllabus, welding is there. That is a permanent joining. Permanent joining means if we have to dismantle the parts, we have to remove each part, then we'll have to physically damage. So if we classify from that sense, then it becomes welding, then brazing will be there, then soldering, and of course the last one is adhesive bonding. We'll see one by one each of these. So as I told that what we are going to discuss, that is permanent joining. Permanent joining means if we have to dismantle the part, we'll have to physically damage the parts. Then and only then we can remove each and every parts. Suppose this is stylus which is in my hand. If I'm keeping cap in this one, suppose here I'm keeping cap. If I have to remove this one, I don't need to dismantle this one. Sorry, I don't need to physically damage this one. Simply I can remove this one. But if this this section in this stylus which is permanently joined with this one, if I have to dismantle this one or remove this one, I will have to damage this one. That is the only way. So this is permanent. So that is there in our syllabus. So this we will see in detail. Next is what is difficult to dismantle, and that we have already discussed. The purpose of join is to make them a system. Yeah. Suppose in this stylus itself, suppose cap is there, then this whole section is there, then here one part is there. Then so what is the purpose of the joining? Joining is nothing but we are assembling different parts together to make it a system. So this is joining. So now we will start with the welding process. So welding process, as I told, is a permanent joining process. Means the part will be permanently joined together. And it actually happened at atomic level. So it is a metal joining process in which two or more parts are joined or coalesced together at their contacting surfaces by suitable application of heat or end pressure. Means in many of the processes only heat will be required to join these two parts. In many of the processes heat as well as pressure will be required. In many of the processes we don't need heat, only pressure will be sufficient to join together. So this is the definition of a welding process. Next we'll see what is the advantages of welding processes. So as we discussed, it is a permanent joining. Means if you have joined two parts together, so permanently it will be like that. So during its service or during its use, there will be no problem that one part will come out or another part will come out. You have joined properly. So wherever the joining is, in many of the cases, if all the parameters is kept properly or welding has been done properly, keeping everything is in mind, then the joint part will be more stronger as compared to the parent metal. So this is the permanent joining. So permanently will be joined the parts. Next point is welded joint can be stronger. As I said, in some of the cases with the parent metal. Parent metal means suppose I have to join these two parts. Okay, and these are mild steel blocks. So if I'm writing this one M1 and this one M2, and I have to join this through a butt edge to edge if I have to join. So what is the meaning of this one? In some of the cases, if all the parameters and everything we are keeping properly, so in some of the cases, what we see, the strength of this part where these two parts have been joined together is generally stronger as compared to the base metal. So that had been written the parent materials if the proper filler metal is used and the strength property better than the parent metal of the material and defectless welding means if there is no defect means everything all the parameters in the process has been followed properly. So what will happen in many of the cases the strength of the joint part will be more as compared to the parent metal. It is economical to join components in terms of material uses means if I have to assemble two or more parts together, so always it is economical in the sense of material. Means if I have to combine two or more parts, for example, in this stylus, if I have to join this one with this whole assembly, if I have to put cap over there, so if I'm doing all this through joining operation or if I'm doing all this through welding process, so material what I am going to utilize for this assembly or this whole system always will be less if we compare with the other processes. So other methods of assembly require, for example, if I have to drill holes, then using rivets, if all these things we are doing and finally we'll calculate how much material we have actually used in this particular system, then we'll get to know that the material used is always more than what we used in the welding. So always it is economical to use the welding. So these are the three major advantages of this process. What are these? It is actually permanent joining, and the second one is the join part. Wherever we are doing the joining, is everything is kept properly, all the parameters followed properly, then generally the strength of the part where we have joined is more as compared to the parent metal. And last one is it is generally economical if we compare with the other processes. What are the disadvantages? As most of the process are manual, we do. So of course, labor will be there. Many labors will be used. So labor cost will be high. So generally, it is a costly process. It is dangerous. Suppose we are doing arc welding, so there current will be there and a spatter will be there. So chances of hazardous things will be there. Not only that, if we are using filler or other chemicals over there, so hazardous gases will also come out from that. So in that sense, it is a dangerous process. So we'll have to actually shield or we'll have carefully will have to do the process. So in that sense, it is a dangerous process. Okay, as I said at the starting, so it is a permanent joining process. So it has advantage as well as it has disadvantage also. Means if I have joined two parts together and I want to dismantle without physically damaging, I can't do that. So it may be considered as the advantage of this process as well as this may be considered as a disadvantage of this process. Some of the welding defects cannot be identified, which will reduce. Yeah, many of the defects in during the welding are it's very difficult to identify. For example, if moistures are there and we have not removed completely, then what will happen? Hydrogen embrittlement will be there. Means hydrogen will be hide over there, and once welding will be completed, then chances is very high that there will be embrittlement. Means hydrogen embrittlement. So this is the disadvantage of the process that sometime during the welding it's very difficult to find out what is the defect over there, and finally when the part is being welded and it is being put in a proper application wherever for whatever application it has been manufactured, there finally these defects will come out. So these are the disadvantages of this process. Now, how to classify the welding processes? So actually broadly it is classified in two parts, that is fusion welding, or this is also known as liquid based welding. Liquid welding. So fusion welding or liquid welding, and second one is solid state welding. So what is the meaning of this one? Fusion welding or liquid welding means when we are welding two or more parts together, we'll have to melt the material to join together. Means the material is going to change its state from solid to liquid. If this is happening, means the parent material, the material that we are going to weld, if it is changing its state from solid to liquid, then this is termed as fusion welding, or it is also sometimes termed as liquid state welding. But in second case, if while welding material is not changing its state, although it will be at a very high temperature, but if it is not reaching to its melting temperature, means material is not melting, then it comes under the category of solid state welding process. Okay, so many examples are there. All the fusion welding processes, sorry, arc welding processes comes under this category. Resistance welding comes under this category. We'll see one by one all these processes. Then the gas welding is there, that comes under this category. So all these processes comes under this category. Why? Because when we are welding parts, we have to melt the material. Melt the material means we have to change the state of the material. That's why it is fusion welding or a liquid state welding. And second one is that is solid state welding. There material will not be melted, it will be in its plastic state. Temperature will be very high beyond the recrystallization temperature, but it will not be in molten phase, means it will not be in liquid state. That's why it is known as solid. So many examples are there, like explosive welding is there, then roll bonding is there, friction welding is there, friction stir welding is there. All these welding processes comes under this category. So here that has been written. What is the meaning of fusion welding? In fusion welding process, heat is applied to melt the base metal. Now this heat source, many sources may be. In all the arc welding, arc of course is the source for the heat over there to melt the material. In gas welding, chemical reaction is the source through which we'll get the heat over there. In explosive welding, or explosive will be there, means explosion will be there, and because of that explosion will get the, so different sources are being used in solid state welding. Most of the cases, like friction welding and friction stir welding, friction will be the main source of heat over there to weld the material. So this heat source may be through different ways that will produce heat to weld the material. In many fusion welding processes, a filler metal is being used. Yeah, that is another thing. If filler metal may be used, filler metal may not be used during the welding. So if we are using filler metal, then it is known as, it may be homogeneous welding process or it may be heterogeneous, depending upon if these are the parent metals. Suppose this is the one metal and this is the another metal that I am going to weld. And if I am using a filler metal, suppose this is the filler metal I am using during the welding, and this is having the same nature as the parent metal. Suppose these two are M1, M2. M1, M2 means this is mild steel piece 1 and this is mild steel piece 2. If I am using a filler and this filler is having same nature, means this is also mild steel, then this is known as homogeneous welding. This is one of the classification of the welding. But if I'm not using any filler during the welding, then the process is known as autogeneous. So here it is given. If there is no filler used during the welding, this process is known as autogeneous welding. And if filler we are using and it is having different nature, for example, this is mild steel, this is mild steel, and this is not mild steel, this is something else. If we are using as a filler, then it is known as heterogeneous welding process. So this is also another way of classification of welding processes. What is that? If filler we are not using during the process, many processes are there where we do not use filler, like friction welding is there, FW. Friction star welding is there. There will be no filler over there. All resistance welding is there. Resistance welding. There also there will be no filler. Gas welding is there. There also there is no filler. Sorry, gas welding it is used. Sorry, in gas welding filler is used. So these processes are there. Resistance welding is there, friction welding is there, fixed stir welding is there, explosive welding is there, then roll bending is there. In all these processes there will be no filler over there. So if filler we are not using, this is known as autogeneous process. Another classification is there. If filler we are using and it is having the same nature of the base metal that we are going to join, it is known as homogeneous process. And if the filler used is different uh, from the parent metal, then it is known as heterogeneous welding process. So here it has been given, example has been given. Arc welding, not all arc weldings. In arc welding, filler is generally used. Okay, na, it may be consumable, not consumable. Then resistance welding is there, oxy-fuel gas welding is there, electron beam welding is there, and laser welding is there. Thank you. We'll stop this lecture here, and we'll take in next lecture. We'll take the another topic. Thank you.